Okay, so for Unit 4, Unit 4 covers rational expressions. We're going to go ahead and cover the first section of this unit, 6.1, which is about simplifying rational expressions. So anytime you hear me say rational, okay, the easiest and most simplest way to put what a rational expression is, I just want you to think of a fraction. So a rational expression is a fraction which includes polynomial expressions in the numerator and or the denominator, okay? And so what this would look like, all right, for example, 1 divided by x, that would be considered a rational expression. X minus 2 over x plus 3, another rational. Again, look at this. This would be a polynomial. This is also a polynomial, and it's also a fraction. So fractions with a bunch of stuff in it, basically. And the last one, a little bit more to this example. All right, so anytime we're dealing with rationals, this is what your problems would typically look like. Okay, so moving forward, we're going to go ahead and talk about evaluating your rational expressions. And so again, if you can recall, when you're evaluating something, okay, you're trying to find the value. Okay, so find the value of that expression, and that typically means you're plugging something in. So remember, you're plugging something in, and you're going to get a value as the answer. I should put 4x for the variable. All right, and so to give you an example of this, I want you to evaluate the following. So evaluate when x equals 1 for the following expression. So let's say I give you, I don't know, 3x plus 6 over 2x minus 4. Okay, again, when it says to evaluate, you're going to take your x equals 1 and you're just going to plug it in place anytime you see an x. Okay, and then your output should just be a value or a number. So, to show your work for this part, so when x equals 1, again, all you're doing is you're going to replace your x with this value right here. So 3 times 1 plus 6 over 2 times 1 minus 4. Again, you're just plugging the numbers in. And then you just simplify. So 3 times 1 is 3 plus 6 over 2 times 1, which is 2 minus 4. All right, continuing to simplify this fraction. 3 plus 6 is 9. 2 minus 4 is negative 2. And that is the value that you get when you plug or evaluate x equals 1. All right, let me give you one more example. So let's say I want you to evaluate when x equals negative 2. And we're going to go ahead and use the same expression from the previous example. Okay, so again, all you're doing is you're just plugging the number negative 2 in the expression. So when x equals negative 2, you get 3 times negative 2 plus 6 over 2 times negative 2 minus 4. Okay, so again, multiplying everything on the top, 3 times negative 2 is negative 6 plus 6. 2 times negative 2 is negative 4 minus 4. And then when we simplify this, negative 6 plus 6 is 0. Negative 4 minus 4 is negative 8. If you were to plug this into your calculator, 0 divided by negative 8, your output or your value should be 0. Okay, so that is what happens when you evaluate an expression. Okay, all you're doing, you're just plugging the numbers in and you're getting an answer for that. So your number is just going to be the answer. All right, moving on to the next portion of the notes. Okay, we're going to go ahead and talk about what undefined means. So when we have something that is undefined, it's any expression that is divided by 0, or there's a 0 in the denominator. Okay, and so I wrote down some key points here for you. So a rational expression can't have a 0 in the denominator. And when this happens, okay, it says this sometimes places a restriction on what x can be. What that means, it just means that you are limiting your x values that you can plug into that expression. And so when this happens, we denote it by this right here. And so that says x cannot equal whatever. So again, it looks like a little equal sign, like a normal equal sign, but there's like a slash in it. So this just means does not equal, or it can't equal whatever that value is. Okay, and so for example, let's say you have something like this. So for something to look undefined, all right, it would look something like this. So let's say you have 4x over 0. Or you could have something like this, for example, 2 over 0. Okay, so what I want to express here is the reason why this is undefined. Let me use this one as an example here. So let's say you have like 2 pieces of candy and you want to divide it out to nobody. Like, how would you do that? So that's why this would be undefined. If you were to plug this into your calculator, all right, if you put 2 divided by 0 in your calculator, you should get an error, okay, because again, you can't do that. And so another example of what a rational expression would look like if something were undefined, let's say you have 2 over x minus 2. Okay, so again, when you look at this right here, our denominator cannot equal 0. So for this, we have to actually find what would make it 0. And so to do that, all you would have to do is set the denominator equal to 0. So if I do that, I'm going to just solve for x. So if I add 2 to both sides, all right, you get x equals 2. And so what this means is if I were to check myself and I take this value, again evaluating, and I plug it back into this original expression, 2 over 2 minus 2, all right, that gives you 2 over 0. And again, we cannot have that. That would make it undefined. Okay, and so with that concept still fresh on your mind, let's go ahead and do some example problems here. So here it's saying find the values that make the expression undefined. Okay, so again, really and truly, you just don't want the denominators to equal 0. So don't want your denominators to equal 0. So what would make it 0? I forgot to put that up here in this one. This one right here, the 2 over x minus 2. Since we said that if we plug 2 in, you're going to get a 0 on the bottom, we can't have that there. Okay, and so with that in mind, we're going to do the same process for these examples here. So you don't really have to worry about the numerator. We're just checking for the denominator. And so all you have to do is take your denominator, so x minus 3, and set that equal to 0. And then you just solve for x. So I'm going to add 3 to both sides, so x equals 3. So again, if you were to take the value x equals 3 and you plug it into this entire function, all right, I'm not worried about what happens on the top. If I put this in, 3 minus 3, you're automatically going to get a 0 on the bottom. And so with that being said, when we solve for this, x cannot equal 3. All right, so that value makes it undefined. All right, let's do the next one. Again, not worrying about the numerator too much. I'm just worried about what happens on the bottom. So again, we have 3x plus 2, and then you set that equal to 0. Okay, I'm going to subtract 2 from both sides. 3x equals negative 2, because again, all I want to do is just get the x by itself. We're trying to find what do I plug into here that will give me a 0. So now we're going to go ahead and divide both sides by 3. And so x equals negative 2 over 3. Again, if I were to take this value and plug it into our original expression, you're going to get a 0 on the bottom. So your x cannot equal negative 2 over 3. Okay, and then moving on to our last example. So I want you to just take a quick look at it. You have a trinomial, okay? Where does that come from? Well, 1, 2, 3 terms. It's a polynomial with 3 terms, and if you can recall from the previous unit, we factored this a bunch. And so if you look at it, setting it equal to 0 and trying to find what your values are is a little bit difficult when it's in this form. Okay, so what you would have to do for this, you would have to factor this. Okay, and so when you do this, all right, again, just taking the denominator, m squared minus 5m plus 6 equals 0. All right, you can't just really move the 6 over and then move the 5 over because you have variables both here and here. So what you need to do is you need to factor it. And so to the side, what I'll do is still factor like how we normally did before. So I'm going to move this over here. So find your factors of 6, okay, that are going to add, because we have this plus here, to give you a negative 5. All right, so I know that 1 plus 6 won't give me a 5. 2 plus 3 does give me a 5. But to get a negative, we're going to have to do negative 2 plus negative 3. So I'm going to use this combination. Again, setting up your pairs of factors. Okay, we're still going to set it equal to 0 because we're trying to find what those values are. M and m, because m times m gives you m squared. And I already said we're going to use 2 and 3, and they both have to be negative. Okay, so now you have your pairs of factors set up. And so what you need to do now is you need to set m minus 2 equal to 0 and m minus 3 equal to 0. So the reason why we have 2 solutions, okay, this is the fundamental theorem of algebra right here. Whatever this exponent is right here in the front is going to tell you how many solutions that you have. Okay, and so that's why we have 2 solutions. So the first one, m minus 2 equals 0. You add 2 to both sides. So m equals positive 2. And then we find the next one. Add 3 to both sides. M equals 3. Again, we're trying to find what can't you plug in. So we have this here, your final answer. You can't plug in 2, because if you plug in 2 into here, you're going to get a 0 on the bottom. And you also can't plug in 3, because again, if you plug 3 in, you're going to get a 0 here. Okay, so that is undefined, dealing with your rational expressions. All right, and the last portion of the notes that we're going to cover, we're going to go ahead and talk about lowest terms. Okay, so your lowest terms, to put that simply, just means you're going to reduce. So if you look at the little note that I made here, it says cancel the common factors of the numerator and the denominator. So for example, again, we're dealing with fractions. Let's say I give you a fraction like this, so 12 over 20, and I want you to reduce it or put it in its lowest terms. Well, I know that I could divide the top by 4 and the bottom by 4. So I know 4 times 3 gives you 12, 4 times 5 gives you 20. And so here, if I were to reduce this or cancel something out, I notice that my 4's cancel out, and all you're left with is that 3 over 5. Okay, and that's what it is in the lowest terms. All right, let me give you another example. Let's say you have something like this. So 3 times x plus 4 over 7 times x plus 4. Okay, so what do they have in common here? Well, they both have the x plus 4s. So I can cancel those out because, again, anything over itself is just 1. So that's why they just go away. And what you're left with is 3 over 7. So there is the lowest terms for that problem there. Okay, and so I want you to put this in your notes. So if the expressions are not factored, okay, you must find the factors in order to reduce. All right, so let me give you some examples on what this is. Okay, so again, rational expressions, we're going to have probably a polynomial on the top and the bottom. And so the way that you would do this is you would have to factor. Again, factoring does not go away from this point forward, so this will kind of help you brush up on those techniques. So if you look at this right here, automatically it's kind of hard to tell what you can cancel out. You can't just go like, oh, there's a 12, I can take a 2 out, and then you have a 6, and then this will be like a 10. Like, that's just not how that works. What you need to do, okay, is you're going to have to factor the top and the bottom. And so when we're dealing with this, okay, I want you to focus on it like section by section. And so for the purpose of this, I will color code so that way you can see. So it's really like you're factoring 2 problems in one. Okay, so for the numerator, all right, we have 3x minus 12. So we can take out a greatest common factor. So remember your GCF, all right? I know that I can take out a 3. 3 is the greatest common factor. So if I were to divide this term by 3 and this term by 3, again, when you take out your GCF, it doesn't go away. It just kind of just hangs out there on the side. This first part right here, 3 divided by 3 is just 1, so you're left with x. And then 12 divided by 3 is 4. So here is what the numerator would look like when we factor this out. Okay, so again, for visual purposes, let me go ahead and number this one. So now I'm going to work on the denominator. So we have 5x minus 20. So here you're going to find the GCF for this one. So here I know that I can take out a 5 from both terms here. That is the greatest common factor for this one. And so again, the 5 comes out here, and we just simplify. 5 divided by 5 is just 1, and you're left with x. And then 20 divided by 5 is 4. So that's what's going to go on the bottom. So 5 times x minus 4. And so now, after you have factored that, you can clearly see what you are going to cancel. So they both have an x minus 4, so that is what I will cancel out. And you're left with your 3 over 5. Okay, so that is how you put this in its lowest terms. Okay, so let's go ahead and do another example. Let's say you have something like this. So m squared plus 2m minus 8 over 2m squared minus m minus 6. So again, y'all, really and truly, it's just kind of like you're factoring multiple things. And so I would highly suggest working everything out section by section. So again, for visual purposes, I'm going to go ahead and make my numerator green and my denominator red, so you can see the work for each portion. So let's go ahead and focus on the top. So m squared plus 2m minus 8. So first you have to ask yourself, can you take out a greatest common factor? For this one, there isn't anything. And so now we're going to go ahead and just factor like normal. This is a trinomial, so we're going to go ahead and do the method where we find your factors of 8. All right, 1 times 8 is 8, 2 times 4 is also 8. And you have to ask yourself, since this is a minus, which combination is going to subtract to give you this middle term right here. All right, I know that 1 minus 8 isn't going to give me 2. 8 minus 1 won't give me 2. 2 minus 4 gives you negative 2. 4 minus 2 gives you positive 2. So we're going to go ahead and use this one right here. So set up your pairs of parentheses. We have m and m. I said 2 and 4. 4 minus 2. So that makes the 2 negative and the 4 positive. All right, so there is the numerator. So we have m minus 2 times m plus 4. All right, let's go ahead and do the denominator. So 2m squared minus m minus 6. So again, ask yourself, is there a greatest common factor? I don't see one, but we do have a coefficient in this front here. So remember, this is where we're going to use your MAC method. So again, to kind of remind you what this technique is, you're going to take your 2 and you're going to multiply it to the 6. So again, you're going to multiply A and C together. So we're going to be left with m squared minus m minus 12. All right, and then now you're going to go ahead and just do the factoring like normal. So find your factors of 12 that will subtract, because we have that minus here. So 1 times 12, 2 times 6, 3 times 4. So which one will subtract to give you this negative 1? All right, I know that 1 minus 12 won't work. 12 minus 1 won't. 2 minus 6, 6 minus 2 is not going to work. 3 minus 4 does give you negative 1, so I'm going to use that. So m and m, I said 3 and 4. So positive 3 minus 4 will give you that negative 1 in the middle. Right? So again, the most important part for the MAC method, remember, you need to pay MAC back. All right, so again, this is really going to help you brush up on those factoring techniques. So we're going to divide this by 2 and this by 2. Again, where does that come from? We started with here. We multiplied that to the C, or the 6. And so to pay MAC back, you have to do the inverse of multiplication, which is why we divide. And so we're going to divide that by the number that we multiplied in the beginning. All right, so if you can reduce, reduce. So this one right here, m minus 4 divided by 2, is going to give you 2, because 4 divided by 2 is 2. This one, I can't reduce this fraction, so I'm going to go ahead and move my 2 in front of that variable. So you're going to have 2m plus 3. All right, and there is the factor portion for the denominator. So we have this going on. All right, and now you can clearly see what we can cancel out. So again, if you just leave it like this, it's kind of hard to just see what will cancel out for this one. So I can see that m minus 2's will cancel out, and all you're left with is this. So your answer is going to be m plus 4 over 2m plus 3. All right, and that is how you put the rational